question involves a utility offering primary metering to larger commercial or industrial facilities where the service point is changing. Typically, the utility would own the power transformer and define the point of service as the secondary bushings of the transformer. Now, after primary metering is installed, the utility is transferring ownership of the transformers to the customer, along with the medium voltage cabling. Specifically, Section 490.22 requires a means of isolation for equipment, which by default would become the service disconnect. The question then is, does 490.22 actually require a disconnecting means to be located on the primary side of the transformer? And what other National Electrical Code implications would come into play with this change of ownership? Answering requires more information. Owners of electrical equipment are required by the National Electrical Code to provide the necessary safeguards for their equipment and employees who may come into contact with it. This includes the requirements of 490.22. In the past, the electrical utility provided the disconnect to the equipment because they owned the equipment. Now, with the ownership being transferred, this responsibility now rests with the owner of the equipment. In the case of the transformer being the service equipment, 490.22 requires a means for isolating the equipment for service, and the condition in 490.22 applies, specifically 490.22a3. This requires a readily accessible disconnecting means located within sight of the equipment to disconnect the load end from all ungrounded conductors. This is to be the service disconnect for the system. The new owner of the transformers will be required to install proper guarding and isolation devices to meet the requirements of 490.22 for the transformers. Further, 110.26 requires accessible disconnecting means to disconnect all of the equipment from both supply conductors at a single point. In the case of the transformers being the service equipment, the disconnects must be accessible and located outside of the building or structure if they meet the requirements of 110.26 done and all the other applicable requirements of 110.26. This may require an additional disconnect on the primary side to meet the requirements of 110.26 since the disconnect at the load is not considered equipment mounted. The utility should also be providing the new owner with their requirements for the operation and maintenance of the service equipment. Now let us analyze this in detail. Firstly, 490.22 is about isolation. This section of the National Electrical Code, NEC, addresses the need for isolating medium voltage equipment for maintenance and safety purposes. When the utility owned the transformer, they were responsible for providing this isolation. Now that the customer owns the transformer, that responsibility shifts to the customer. Secondly, 490.22 is about readily accessible disconnecting means. This subsection specifically requires a readily accessible disconnecting means within sight of the equipment to disconnect the load end from all ungrounded conductors. This disconnecting means serves as the service disconnect for the system. The phrase readily accessible is important. It means the disconnect must be easily reached without obstacles or the need to climb or remove barriers. The phrase within sight means that the disconnect must be visible from the equipment it disconnects. This ensures that someone working on the equipment can verify that it is energized. Thirdly, 110.26 is about workspaces and access. Section 110.26 deals with workspace about electrical equipment, ensuring adequate space for personnel to safely operate and maintain the equipment. This includes providing sufficient access and egress. When the transformer is the service equipment, the disconnects must be accessible and located outside the building or structure if 110.26 done requirements are met. If these requirements cannot be met, then the disconnect must be located elsewhere in compliance with 110.26. Fourthly, additional disconnect requirements are sometimes needed. An additional disconnect on the primary side may be needed to meet the requirements of 110.26. particularly if the disconnect at the load end is not considered equipment mounted. This means that if the load side disconnect is not directly attached to the equipment or does not meet the accessibility requirements, a separate disconnect on the primary side may be necessary. Fifthly, utility requirements for operation and maintenance must be followed. The utility should provide the new owner with their specific requirements for operating and maintaining the service equipment. These requirements may include specific procedures, maintenance schedules, and safety protocols that the customer must adhere to. Sixthly, guarding and isolation are essential. The new owner must install proper guarding and isolation devices to meet the requirements of 490.22 for the transformers. This includes physical barriers, enclosures, or other means to prevent unauthorized access and protect personnel from accidental contact with energized parts. Seventhly, safety is paramount. All installations and modifications must comply with applicable safety standards and regulations to protect personnel and prevent electrical hazards. This includes proper grounding, bonding, and overcurrent protection. Eighthly, professional consultation should be considered. Given the complexity of medium voltage systems and the potential hazards involved, it is advisable to consult with qualified electrical engineers or contractors to ensure compliance with all applicable codes and standards. Ninthly, documentation is important. Maintain detailed records of all inspections, maintenance, and repairs performed on the electrical equipment. This documentation can be helpful for demonstrating compliance with regulatory requirements and identifying potential problems before they lead to equipment failure or safety hazards. Tenthly, training is essential. Ensure that all personnel who will be working on or around the electrical equipment are properly trained in safe work practices and procedures. This includes training on lockout/tagout procedures, personal protective equipment, and emergency response. Now let us discuss NEC 490.22 in detail. Section 490.22 of the National Electrical Code NEC pertains to the isolation of equipment operating at more than 600 volts nominal. This is crucial for ensuring the safety of personnel who may need to work on or near such equipment. The main requirement is that a means must be provided to isolate the equipment for service. This isolation prevents accidental energization of the equipment while it is being worked on, thereby reducing the risk of electrical shock and other hazards. The requirements of 490.22 apply when the transformer is the service equipment. This subsection further specifies the conditions under which a disconnecting means is required. Specifically, 490.22 A3 states that a readily accessible disconnecting means must be located within sight of the equipment. This disconnecting means must be capable of disconnecting the load end from all ungrounded conductors. There are two key phrases here: readily accessible and within sight. Readily accessible means that the disconnecting means must be easily reached without the need to climb over obstacles or remove barriers. This ensures that in an emergency or during routine maintenance, the disconnect can be quickly accessed. Within sight means that the disconnecting means must be visible from the equipment it controls. This allows the person operating the disconnect to visually confirm that the equipment is indeed energized before starting any work. The disconnecting means required by 490.22 A3 serves as the service disconnect for the system. The service disconnect is the main switch that controls the entire electrical supply to a building or a specific portion of it. It is used to completely shut off power to the equipment for maintenance, repairs, or in case of an emergency. Given that the utility is now transferring ownership of the transformers to the customer, the new owner is responsible for ensuring compliance with 490.22. This includes installing the necessary disconnecting means and ensuring that it meets the requirements of being readily accessible and within sight of the equipment. The new owner must also provide proper guarding and isolation devices to meet the requirements of 490.22 for the transformers. These devices can include physical barriers, enclosures, or other means to prevent unauthorized access and protect personnel from accidental contact with energized parts. Another important consideration is Section 110.26 of the NEC, which deals with workspaces about electrical equipment. This section requires that sufficient space be provided around electrical equipment to allow for safe operation and maintenance. In the context of the transformers being the service equipment, 110.26 requires accessible disconnecting means to disconnect all of the equipment from both supply conductors at a single point. This means that there must be a way to completely de-energize the equipment from both the source and load sides. If the disconnecting means are located outside the building or structure, they must comply with 110.26 done. This subsection specifies additional requirements for outdoor installations, such as the need for weatherproof enclosures and adequate working space. It's important to note that the requirements of 110.26 apply in addition to those of 490.22. While 490.22 focuses on the isolation of the equipment itself, 110.26 addresses the overall safety of the workspace around the equipment. In some cases, an additional disconnect may be required on the primary side of the transformer to meet the requirements of 110.26. This is particularly true if the disconnect at the load end is not considered equipment mounted. For example, if the load side disconnect is located in a separate room or is not easily accessible, a separate disconnect on the primary side may be necessary to ensure compliance with 110.26. Finally, it's important for the new owner of the transformers to obtain the utilities requirements for the operation and maintenance of the service equipment. These requirements may include specific procedures, maintenance schedules, and safety protocols that the customer must adhere to. By understanding and complying with the requirements of 490.22, 110.26, and the utilities guidelines, the new owner can ensure the safety of personnel and the reliable operation of the electrical system. Now let us look at possible scenarios. Scenario 1 is a straightforward case. A manufacturing facility takes ownership of a utility transformer with a readily accessible disconnect within sight of the transformer. The disconnect meets all requirements of 490.22 ATHRI. The workspace around the transformer and disconnect complies with 110.26, including adequate access and working space. In this case, no additional disconnects are required. The existing disconnect serves as the service disconnect, and the facility can safely operate and maintain the equipment. Scenario 2 is slightly different. In a large industrial complex, the transformer is located in a secure vault with limited access. The load side disconnect is not readily accessible and is not within sight of the transformer. The workspace around the transformer is also limited, making it difficult to comply with 110.26. In this scenario, an additional disconnect is required on the primary side of the transformer to meet the requirements of both 490.22 and 110.26. The primary side disconnect must be readily accessible and located in a safe and accessible workspace. Scenario 3 is a bit more complex. A commercial building takes ownership of a utility transformer. The transformer is located outdoors, and the load side disconnect is located inside the building. The utility requires a disconnect on the primary side for safety and maintenance purposes. The primary side disconnect must comply with 110.26 done, including weatherproof enclosure and adequate working space. In this case, the building owner must install a primary side disconnect that meets the utilities requirements and complies with all applicable codes and standards. Now let's discuss best practices to use. Firstly, conduct a thorough assessment of the existing electrical system. This includes evaluating the location of the transformer, the accessibility of the disconnects, and the compliance with 490.22 and 110.26. Secondly, consult with qualified electrical engineers or contractors. This will help to ensure that the installation meets all applicable codes and standards and that the equipment is safe to operate and maintain. Thirdly, obtain the utilities requirements for the operation and maintenance of the service equipment. This will help to ensure that the facility is in compliance with the utilities guidelines and that the equipment is properly maintained. Fourthly, install proper guarding and isolation devices to prevent unauthorized access and protect personnel from accidental contact with energized parts. Fifthly, provide adequate training to personnel who will be working on or around the electrical equipment. This includes training on safe work practices, lockout/tagout procedures, and emergency response. Sixthly, maintain detailed records of all inspections, maintenance, and repairs performed on the electrical equipment. This will help to demonstrate compliance with regulatory requirements and identify potential problems before they lead to equipment failure or safety hazards. Seventhly, implement a comprehensive safety program that includes regular inspections, maintenance, and training. This will help to ensure that the electrical system is safe to operate and maintain and that personnel are protected from electrical hazards. Let's dive deeper into each section of the National Electrical Code, beginning with Section 490.22, and look at isolation of equipment. Section 490.22 of the NEC mandates that means must be in place to isolate electrical equipment operating at over 600 volts. This is primarily to ensure safety during maintenance, repairs, or any situation where personnel might come into contact with the equipment. Without proper isolation, there's a significant risk of electrical shock or arc flash, which can lead to severe injuries or fatalities. Secondly, disconnecting means. A key component of isolating equipment is having a reliable disconnecting means. This is essentially a switch or circuit breaker that can completely cut off the power supply to the equipment. It must be rated for the voltage and current levels of the system and be designed to safely interrupt the flow of electricity. Thirdly, readily accessible. The disconnecting means must be readily accessible. This means it should be easy to reach without having to climb over obstacles, move equipment, or navigate through confined spaces. Accessibility is crucial for quick response in emergencies and for efficient maintenance procedures. Fourthly, within sight. The disconnecting means should be within sight of the equipment it isolates. This allows the person operating the disconnect to visually confirm that the equipment is indeed energized before starting any work. It's a simple yet effective way to prevent accidental energization. Fifthly, service disconnect. In many cases, the disconnecting means required by 490.22 also serves as the service disconnect for the electrical system. This is the main switch that controls the entire power supply to a building or facility. It's used to completely shut off power for maintenance, repairs, or in case of an emergency. Sixthly, guarding and isolation. Proper guarding and isolation devices are necessary to prevent unauthorized access and protect personnel from accidental contact with energized parts. This might include physical barriers, enclosures, or insulated covers. Seventhly, owner responsibility. With the transfer of ownership of the transformers from the utility to the customer, the responsibility for ensuring compliance with 490.22 shifts to the new owner. This includes installing the necessary disconnecting means, providing proper guarding, and ensuring that the equipment is maintained in a safe condition. Now let's analyze 110.26. Section 110.26 of the NEC focuses on workspaces around electrical equipment. It aims to provide enough room and safe conditions for personnel to operate and maintain the equipment without undue risk. Firstly, adequate space. This section requires adequate space around electrical equipment to allow for safe operation and maintenance. The specific amount of space required depends on the voltage of the equipment and the configuration of the installation. Secondly, access and egress. There must be clear and unobstructed access to and egress from the workspace. This means that personnel should be able to easily enter and exit the area without having to navigate through obstacles or confined spaces. Thirdly, headroom. Sufficient headroom is required in the workspace. This helps to prevent accidental contact with energized parts and allows personnel to work comfortably and safely. Fourthly, illumination. Adequate illumination is necessary to ensure that personnel can see what they are doing and identify potential hazards. The lighting should be sufficient to allow for safe operation and maintenance of the equipment. Fifthly, dedicated equipment space. In some cases, dedicated equipment space is required for electrical equipment. This means that the space should be used exclusively for the equipment and should not be used for storage or other purposes. Sixthly, outdoor installations. For outdoor installations, 110.26 done requires that the equipment be protected from the weather and that adequate working space be provided. This might include weatherproof enclosures, shelters, or other means of protection. Seventhly, disconnect location. The location of the disconnecting means is also important. It should be readily accessible and located in a safe and convenient location. It should also be clearly marked and labeled so that personnel can easily identify it. Eighthly, single-point disconnect. 110.26 requires accessible disconnecting means to disconnect all of the equipment from both supply conductors at a single point. This ensures that the equipment can be completely de-energized for maintenance or in case of an emergency. Ninthly, coordination with 490.22. It's important to coordinate the requirements of 110.26 with those of 490.22. While 490.22 focuses on the isolation of the equipment itself, 110.26 addresses the overall safety of the workspace around the equipment. Both sections must be considered to ensure safe and compliant installation. Understanding both NEC sections are important. The new owner of the transformer must navigate a complex set of requirements to ensure compliance and safety. The transfer of ownership from the utility to the customer places new responsibilities on the customer, including the need to provide proper isolation, guarding, and maintenance for the equipment. By understanding the requirements of 490.22 and 110.26, the customer can ensure that the electrical system is safe and reliable. It's also important to consult with qualified electrical engineers or contractors to ensure that the installation meets all applicable codes and standards. In addition to the NEC requirements, the utility may have its own standards and guidelines for the operation and maintenance of the service equipment. The new owner should obtain these requirements and ensure that they are followed. This might include specific procedures for switching, grounding, and testing the equipment. It's also important to maintain detailed records of all inspections, maintenance, and repairs performed on the electrical equipment. This can help to demonstrate compliance with regulatory requirements and identify potential problems before they lead to equipment failure or safety hazards. Ultimately, the goal is to ensure that the electrical system is safe, reliable, and compliant with all applicable codes and standards. This requires a comprehensive approach that includes proper design, installation, maintenance, and training. The new owner of the transformer must be proactive in addressing these issues and must work closely with qualified professionals to ensure that the electrical system is properly managed. In summary, the transfer of ownership of utility transformers to customers brings with it a new set of responsibilities. The new owner must ensure compliance with NEC sections 490.22 and 110.26, as well as any applicable utility requirements. This includes providing proper isolation, guarding, and maintenance for the equipment, as well as ensuring that the workspace around the equipment is safe and accessible. By understanding these requirements and working with qualified professionals, the new owner can ensure that the electrical system is safe, reliable, and compliant with all applicable codes and standards. Let us discuss lockout-tagout procedures. Lockout/tagout loader procedures are essential for ensuring the safety of personnel working on or near electrical equipment. These procedures are designed to prevent accidental energization of the equipment while it is being worked on, thereby reducing the risk of electrical shock and other hazards. Firstly, identify all energy sources. The first step in a LOTO procedure is to identify all potential sources of energy that could energize the equipment. This might include electrical, mechanical, hydraulic, pneumatic, or thermal energy sources. Secondly, notify all affected personnel. Before starting any LOTO procedure, it's important to notify all affected personnel that the equipment will be de-energized. This might include workers in the immediate area, as well as those in other parts of the facility who might be affected by the shutdown. Thirdly, shut down the equipment. Once all affected personnel have been notified, the equipment should be shut down using normal operating procedures. This might involve turning off switches, closing valves, or disconnecting power supplies. Fourthly, isolate the equipment from all energy sources. After the equipment has been shut down, it must be isolated from all potential sources of energy. This might involve disconnecting electrical circuits, closing valves, or blocking mechanical movement. Fifthly, apply lockout/tagout devices. Once the equipment has been isolated from all energy sources, lockout/tagout devices should be applied to the energy isolating devices. Lockout devices are physical locks that prevent the energy isolating device from being turned on. Tagout devices are tags that warn personnel not to turn on the energy isolating device. Sixthly, verify that the equipment is de-energized. After lockout/tagout devices have been applied, it's important to verify that the equipment is indeed de-energized. This might involve using a voltmeter to check for voltage, or attempting to operate the equipment to see if it starts up. Seventhly, perform the work. Once the equipment has been verified to be de-energized, the work can be performed safely. It's important to follow all safety procedures and to use appropriate personal protective equipment. Eighthly, remove lockout/tagout devices. After the work has been completed, the lockout/tagout devices can be removed. This should only be done by the person who applied the devices, and only after verifying that the equipment is safe to be re-energized. Ninthly, notify all affected personnel. Before re-energizing the equipment, it's important to notify all affected personnel that the equipment will be turned back on. This will give them time to move to a safe location and to prepare for the restart. Tenthly, re-energize the equipment. Once all affected personnel have been notified, the equipment can be re-energized using normal operating procedures. It's important to monitor the equipment closely during the restart to ensure that it is operating properly. Implementing a comprehensive LOTO program requires careful planning and training. All personnel who will be working on the electrical equipment should be trained in LOTO procedures and should be familiar with the specific requirements of their workplace. The LOTO program should also be regularly reviewed and updated to ensure that it remains effective and compliant with all applicable regulations. In addition to the basic LOTO procedures, there are a number of other factors that should be considered when developing a LOTO program. These include, firstly, equipment-specific procedures. Different types of equipment may require different LOTO procedures. It's important to develop equipment-specific procedures that address the unique hazards associated with each type of equipment. Secondly, group LOTO procedures. In some cases, it may be necessary to use group LOTO procedures when multiple workers are working on the same equipment. Group LOTO procedures ensure that all workers are protected and that the equipment cannot be re-energized until all workers have completed their work. Thirdly, contractor LOTO procedures. If contractors are working on electrical equipment, it's important to ensure that they are following the same LOTO procedures as the facility's employees. This might involve providing training to the contractors or requiring them to follow the facility's LOTO program. Fourthly, periodic inspections. Periodic inspections of the LOTO program should be conducted to ensure that it is being followed correctly. The inspection should be documented and any deficiencies should be corrected promptly. Fifthly, program audits. Periodic audits of the LOTO program should be conducted to ensure that it is effective and compliant with all applicable regulations. The audit should be conducted by qualified personnel and should be documented. By implementing a comprehensive LOTO program, facilities could significantly reduce the risk of electrical accidents and injuries. LOTO procedures are an essential part of any electrical safety program and should be followed diligently by all personnel. The key is consistent application of the rules. All of these procedures must be followed every single time work is being performed and cannot be avoided. By ensuring that the new owner of the electrical transformer equipment is knowledgeable about all aspects of the NEC and safety standards and any local utility rules, the transition of ownership from the utility company to the customer will result in a safe and reliable transfer.